Diagram chemistry summary. Before last week, we talked about what are these ionic bonding. Cation releasing electrons makes this plus charge. Anions gaining electrons make this minus charge. So the permanent negative, permanent positive are there, not partial, complete negative, complete positive. Between them, they are making this strongest electrostatic interaction, which we call the ionic bonding. So between them, the strongest electrostatic interactions are making, so those are called the ionic bonding. So then the last week we talked about, today we talked about these factors favoring this formation of ionic bonding. So if it is for cation, ionization energy is supposed to be lower, so they are absorbing less energy. Endothermic, so that thermodynamically more stable when they are gaining less energy. And for anion, it's electron gain energy, so they have to lose electrons. They have to they have to get electrons in. So that's called the electron gain. Electron gain energy can be negative and positive. If it is negative, losing electrons, exothermic, so that the molecule is more stable. So that the electron gain energy of anion is supposed to be greatly negative. And then the third one is valence shell electron number. How many electrons are in the valence shell? When for cations, valence electrons is supposed to be less, so that they release electrons by gaining energy, so the less energy they can gain when they have less electrons. For anions, very easily they can reach this inert configuration when there are 5, 6 and 7 electrons in the last shell. And then the last one is the electronegativity difference. You guys know that electronegativity difference definitely is supposed to be greater than 2.1. Then we talked about the properties of compounds, ionic compounds. The very first one is the physical state. You guys know with this solid negative, solid positive, they are making this stronger electrostatic interaction, so that their physical condition is very stronger, so they all are existing as solids. Melting boiling points, electrostatic interactions are very stronger, so that melting boiling points are greater. And then the next one is the electrical conductivity. They conduct electricity not at solid state. They don't conduct electricity at solid state, that because they don't have these mobile ions, but at fused, molten or aqueous state, since they have mobile ions, so that they conduct electricity. And then the next one is the solubility. I told you guys to understand the solubility, we got to wait until we get to the last part of the unit 2, because we got to explain these van der Waals interactions. For now, just think that, remember that ionic compounds are having ions and water is also polar, so that they have these connections, interactions, so that ionic compounds are dissolved well in water. And then the next one is the density. Since the electrostatic interactions are stronger, so they get closer to each other, so that number of particles per unit volume is, or the density, so that is high. So density of ionic compounds are greater. Alright, so the next one is a metallic bond. Who discovered this metallic bond theory? Paul Carl Ludwig Drude and Henrik Lorentz. They together developed this little structure for metallic lattice. So they say metals having less ionization energy, so they itself, since their ionization potential is less, they itself release their electrons just 2 out of the atoms. So they are making cations. These electrons are accumulating around, which is called the electron cloud or electron sea. Electron sea. In that electron sea, the positive charges are laying inside. And then positive charges, this positive charge of the nucleus, and between the electrons, they are making this what interaction? That's again electrostatic interaction, which we call the metallic bond. Nucleus positive charge, electrons negative charge, they make this electrostatic interaction. We call that electrostatic interaction as the metallic bond. So what are the factors favoring the strength of the metallic bond? So the size of cation is supposed to be smaller, then the electrons can get closer to make this stronger attraction. And when the number of electrons in the electron sea is greater, so then with the plus charge they are making stronger attraction. So when the radius of cation is less and when the number of electrons participating for this electron sea is high, the metallic bond strength is greater. Anyway, so we have a couple of these 10 actually different facts to discuss the properties of metals. The very first one is the physical state. You guys know mercury is a liquid and all the others are solid. And then the second one is like always melting boiling points, usually high with the high electrostatic interaction. And then the third one is the electrical conductivity. Yeah, they have this stronger electrostatic interaction, but still it is not that strong as the ionic compound. So these electrons are called mobile electrons. When you supply energy, they can conduct so that electricity. Metallic luster. When electrons of these metals are absorbing energy, they are going to higher energy level. That's unstable. When they are coming back to low energy level, they release energy as radiation. It appears that radiation is coming through the surface, so it shines. That's how we are getting the luster. Density. Lithium, sodium, potassium are floating on water. Density is less than water, but otherwise density is greater than water. And then the heat conductivity. Through the vibration of metallic cations, heat is conducting. Heat conductivity is really high, so that heat capacity is less. They cannot keep heat within. And then malleability and ductility. With the structure, the layers of ions are there. Through these electrons, these layers can pass, the layers can rearrange. So you can hammer into thin sheets or you can draw to make these thin wires so that the malleability and ductility is there. And the sonorosity. This echoing, once you bang something on the metal, that comes through the vibrations of or transmissions of electrons. That's all actually we did for this last week for chemistry. Unit 2, that's a very little part. Then we did Unit 1, the tiered book. Remember, Unit 2 starts from the Lewis. Only when we are studying Lewis, you would feel like that you love this Unit 2 and you love this chemistry. So I want to start the Lewis like very freshly with you guys. So the next week, let's start the Lewis. Okay, this is the Grand Advanced Level Chemistry. I'm Dr. Asha Mathotaarachchi.